350 million years ago, long before the age of dinosaurs, planet Earth looked completely different. Endless tropical swamps, intense humidity, and extremely high oxygen levels in the atmosphere created ideal conditions for life to flourish, though not life as we know it today. The Carboniferous Period was a strange, almost alien era dominated by giant insects. Constantly wet tropical forests absorbed carbon dioxide through photosynthesis and released enormous amounts of oxygen into the atmosphere. This raised oxygen levels to a record 35%, about 1.5 times higher than what is considered safe for humans. Such high oxygen concentrations became a powerful energy source for living organisms. In this primeval jungle world, it was the perfect time for early vertebrates that were just beginning to evolve, though not yet fully adapted to life on land, as well as for invertebrates that grew to astonishing sizes. This was an age of aggressive millipedes, as long as cars, dragonflies soaring through the skies like modern hawks, and giant spiders and scorpions the size of bull terriers that ruled the swampy jungles. The Carboniferous was truly an era when giant insects ruled the planet, turning it into your worst nightmare. If you found yourself in the jungles of the Carboniferous, the first thing you would feel would be mild disorientation, weakness, and blurred vision. This would be caused by the excessive oxygen levels, so high that even a small spark could ignite wet wood. Looking down, you would likely see your feet slowly sinking into mud, a typical feature of this humid environment. But the real spectacle would unfold above your head. If you looked up, you might see what appeared to be birds flying overhead, except their wings produced a loud buzzing and noticeable vibrations in the air. These were enormous prehistoric insects known as Paleotictopterans. The wingspan of an average individual reached about 40 centimeters, while the largest specimens grew up to 55 centimeters, nearly 10 times larger than modern flying insects. Paleotictopterans were among the largest winged creatures of the Carboniferous Period. Their name, meaning ancient net wing, comes from the intricate network-like patterns on their wings. In addition to 2 large pairs of vividly patterned wings, they had small protrusions near the head, likely serving as stabilizers during flight. They also possessed a proboscis used to feed on plant sap, an early example of this feeding adaptation. Despite their massive size, Paleotictopterans posed no threat to humans. They were harmless herbivores interested only in nutrient-rich plant fluids. The same could not be said for one of the most dangerous land predators of the Carboniferous. You would have no trouble spotting it. This was the largest scorpion ever to live, known as Pulmonoscorpius kirktonensis, reaching lengths of up to 70 centimeters. For comparison, the largest modern scorpion, the emperor scorpion, grows to only about 20 centimeters. Pulmonoscorpius had a massive body covered in a thick, chitinous exoskeleton that provided excellent protection from other predators. Its large, powerful pincers with sharp edges allowed it to seize and hold prey, while its curved tail, armed with a venomous stinger, delivered a deadly sentence. It was an active predator that hunted small arthropods, amphibians, and reptiles, both on land and in water. Its partial adaptation to aquatic environments made it a successful hunter in ancient swamps and shallow waters. If you could easily notice this bull terrier-sized scorpion, it would certainly notice you as well. It had 2 pairs of eyes, a central pair for spatial perception, and lateral eyes, likely used for detecting light. Sensory receptors across its body further enhanced its ability to navigate and locate prey. Even if you weren't afraid of spiders before encountering a nearly 70-centimeter venomous scorpion, you probably would be afterward. Now let's return to the skies of the Carboniferous. Alongside peaceful prehistoric insects like Paleotictopterans, The air was ruled by deadly flying predators, creatures that might look surprisingly familiar. These were dragonflies, but on a monstrous scale. Meganeura was one of the largest flying insects of all time. At first glance, it resembled a modern dragonfly, but its size was staggering. Its wingspan reached 65–70 centimeters, and its body length up to 40 centimeters, making it comparable in size to a modern peregrine falcon. Over 300 million years ago, these giant insects were apex aerial predators, dominating the skies of the Carboniferous until the late Permian period, when the first gliding reptiles appeared. Meganeura's enormous compound eyes provided nearly panoramic vision, allowing it to spot prey both above and below. Its powerful spiked legs were perfectly adapted for seizing victims in midair, making it an extremely aggressive and efficient hunter. Its prey often included the very giant insects that filled the skies. Meganeura employed two hunting strategies: ambush, waiting motionless for prey, or active pursuit during flight. Fast and highly maneuverable, it easily avoided obstacles while chasing its targets. Although giant dragonflies ruled the air, life on land still posed challenges, even for the mighty Pulmonoscorpius. One such challenge came in the form of Arthropleura, a true titan among terrestrial invertebrates. Arthropleura was the largest millipede to ever exist, and the largest land invertebrate in Earth's history. Smaller species reached about 30 centimeters, while the largest grew to an unbelievable 2.6 meters in length and weighed up to 50 kilograms. Its body consisted of around 30 armored segments, each up to 50 centimeters wide, with a pair of legs beneath every segment. Like many arthropods, Arthropleura periodically molted its exoskeleton, replacing it with a larger, stronger one as it grew. This incredibly durable armor likely protected it from predators. Encounters with predators were rare, as the Carboniferous had relatively few large land hunters. Even giant scorpions probably avoided attacking creatures several times their size. No fossilized heads or mouthparts of Arthropleura have ever been found, leaving its exact diet uncertain. Scientists believe it primarily fed on plant matter and seeds. Juveniles were likely strict herbivores, while adults may have occasionally scavenged decaying meat or hunted small animals. But the dangers of the Carboniferous forests did not end there. Hidden among the swampy lowlands was yet another predator, lying in wait for small reptiles and amphibians. At first glance, it looked like an unusually large spider, but in reality, it was not a true spider at all. It was a distant relative of sea scorpions, known as megarachne. Its striking resemblance to spiders initially misled paleontologists when its fossils were first discovered, which is why it was given the name megarachne, meaning giant spider. Later research revealed that megarachne was actually a large eurypterid, or sea scorpion. Its body length reached up to half a meter, and its unique anatomy allowed it to feed, using a method known as sediment sweeping. Using paddle-like appendages, megarachne combed through soft sediment in aquatic environments, such as swamps and rivers, capturing and consuming small invertebrates like worms, insects, and smaller arthropods. Occasionally, it may have preyed on land animals such as small reptiles or amphibians. However, these creatures were likely faster and more agile, making them harder targets. Most likely, this sea scorpion lurked in shallow water or riverbeds, waiting for unsuspecting prey to wander too close to its deadly hiding place. When it came to active hunting, however, its ancestors were far more formidable. One such ancestor was Tyrannus, a giant sea scorpion that lived over 400 million years ago. This species was not only more dynamic than megarachne, but also significantly larger. Its length nearly matched that of an average human, reaching about 1.5 meters. And if that seems enormous, it still pales in comparison to an even greater giant, Hibbertopterus. The largest specimens of Hibbertopterus may have reached lengths between 1.8 and 2 meters. These massive creatures were likely among the heaviest of their kind, thanks to their broad, compact bodies. Their feeding method was similar to that of smaller relatives, sediment sweeping, though their diet may have included larger reptiles and amphibians. But even this was not the limit of arthropod gigantism. The largest known representative of these creatures was Jaekelopterus, which lived around 400 million years ago. Its size ranged from 2.2 to 2.5 meters, making it one of the largest arthropods ever discovered. The primary tools for both defense and hunting were its massive claws, which could reach lengths of up to 42 centimeters. These powerful appendages were strong enough to seize and crush prey with ease. Despite its enormous length, comparable to that of a small car, Jaekelopterus likely weighed less than 100 kilograms, due to the relatively simple structure of its body. Not all creatures of the Carboniferous period were affected by this era of gigantism. Among the humid primeval jungles, where the skies were filled with giant dragonflies and the waters concealed massive scorpions, there also existed creatures so small that you might barely notice them beneath your feet. These were known as trigonotarbids, considered prototypes of the first spiders in Earth's history. The smallest species measured only a few millimeters in length, while the largest reached up to 5 centimeters. These early terrestrial arachnids appeared more than 400 million years ago, long before the Carboniferous period. They were fully adapted to breathing air and no longer depended on water. Their appearance closely resembled modern spiders. Their bodies were divided into a cephalothorax and an abdomen, segmented and covered with chitinous plates. Their legs were spider-like as well. However, unlike modern spiders, trigonotarbids could not spin webs. Their cephalothorax was protected by a rigid carapace, earning them the nickname armored spiders. These creatures were among the smallest predators of their time, hunting soft-bodied invertebrates such as worms. They likely did not use venom, instead grasping prey with their legs and holding it while feeding. It is also possible that some species fed on plant material, similar to certain modern mites. The Carboniferous period became a true testing ground for evolutionary experiments. Unique, giant, and often dangerous creatures dominated the land and the air. Yet one of the most fascinating evolutionary experiments of that era took place underwater. There, some of the most heavily armored organisms of the time were formed. Lepidocoleus was an ancient genus of worms that lived around 400 million years ago in what is now Australia. They thrived on shallow reefs and fed on organic debris. Measuring only a few millimeters in size, these creatures could only be examined in detail under a microscope. However, they had another, more memorable name: the Excalibur worm. This name, inspired by the legendary sword of King Arthur, was well-deserved. Visually, they resembled heavily armored knights, covered in overlapping plates of calcite crystals that extended along their entire bodies. This crystalline armor provided exceptional protection. Beneath the crystals lay a lightweight exoskeleton, similar to chainmail beneath a knight's armor. Lepidocoleus could also curl into a ball, shielding its unarmored, and therefore vulnerable, body parts. The sharp edges of its crystal armor made it even more dangerous to potential predators, as these edges protruded outward when the worm curled up. Very few creatures could harm these armored worms. Biting through their crystalline shells was nearly impossible, and swallowing them was an equally bad idea. Evolution had equipped these worms with nearly perfect defense. But this perfection came at a cost. Even this nearly perfect armor had its drawbacks. The heavy shell that protected Lepidocoleus from predators significantly limited its mobility, making it harder to search for food and spread into new habitats. As a result, the Excalibur worm left no significant descendants. Its final extinction coincided with the mass extinction at the end of the Devonian period. Stethecanthus was a small but fearsome prehistoric shark that thrived during the late Devonian and early Carboniferous periods. It reached lengths of up to 90 centimeters and weighed around 9 kilograms. This swift predator posed a constant threat to small fish and even other, smaller sharks. What truly made Stethecanthus unique was the bizarre structure on the backs of adult males, a large, flat, iron-shaped fin. Smooth on top but rough underneath, this strange feature puzzled scientists for decades. Experts now believe this structure functioned as a kind of locking mechanism, helping males attach themselves to females during mating. Determining the exact structure and purpose of this brush-like fin required years of research and fieldwork. When Stethecanthus fossils were first discovered in Europe and North America in the late 19th century, this structure was initially thought to be an entirely new type of fin. It wasn't until the 1970s that scientists realized only males possessed it, and the mating hypothesis gained widespread acceptance. Because of these large dorsal structures, adult male Stethecanthus were likely not fast swimmers. Combined with their specialized teeth, this suggests they were primarily bottom-dwelling predators, though they could pursue slower fish or marine invertebrates when the opportunity arose. Another bizarre predator of ancient seas was Adestus, a massive, shark-like fish that swam the waters of what are now the United States and the United Kingdom. The largest species, Adestus heinrichi, may have exceeded 6 meters in length. This estimate is based on the size of its skull and fossilized teeth. Its upper tooth whorl could reach 30 centimeters, while the lower whorl measured up to 43 centimeters. Adestus earned the nickname the scissor-tooth shark. Its teeth were positioned in the center of its jaws, with each row containing up to 12 serrated teeth. New teeth grew at the back and gradually moved forward, pushing older teeth out at the front. The lower jaw was more curved than the upper one, leading many scientists to believe Adestus used its unique, scissor-like jaws to slice through smaller fish and soft-bodied prey. Studies suggest its jaws moved back and forth using a dual-tooth mechanism in the lower jaw. Although no complete skeletons of Adestus have been found, researchers believe its body likely resembled that of a great white shark, with triangular pectoral fins and a tall, forked tail, making it a fast, open-water predator. Orthocanthus, meaning straight spine, was a massive freshwater fish that reached lengths of up to 10 meters. It lived from the late Carboniferous to the early Permian period, approximately 315 to 275 million years ago. This genus included 12 known species, 2 of which inhabited what is now Texas around 280 million years ago, sharing the landscape with famous Permian animals such as Dimetrodon. Orthocanthus belonged to the Xenacanthidae, a group of cartilaginous fishes known for their unusual spines that existed from the Carboniferous to the Triassic periods. Although they were not true sharks, they were closely related. The most famous member of this group, Xenacanthus, reached about 6 feet in length, and its fossils have been found worldwide in Carboniferous and Permian deposits. Xenacanthids were freshwater species and were likely the largest fish in their environments. An Orthocanthus, measuring around 3 meters, would have been significantly larger than the amphibians it lived alongside, likely occupying the role of apex predator. Studies of coprolites, fossilized feces, from prehistoric freshwater sharks reveal a disturbing behavior: cannibalism during times of food scarcity. Orthocanthus has been identified by the distinctive spiral shape of its fossilized feces, indicating cannibalistic behavior when other food sources were limited. Coprolites discovered in a coal deposit in New Brunswick, Canada, revealed the grim truth: These ancient remains contained fragments of juvenile orthocanthus, providing direct evidence of phylogenetic cannibalism, where adults prey on younger members of their own species, sometimes even their own offspring. This behavior is observed in modern sharks, such as the bull shark, and researchers believe orthocanthus may have occupied a similar ecological niche. Like bull sharks, orthocanthus may have migrated between saltwater and freshwater environments, a unique adaptation that likely played a crucial role in its ability to colonize inland waters. But the age of giant insects and invertebrate rulers of the earth was drawing to a close. Toward the end of the Carboniferous Period, the climate began to change. Forests dried out, oxygen levels in the atmosphere declined, and ecosystems underwent dramatic transformations. These changes proved fatal for many gigantic species, which could no longer sustain their enormous sizes. Gradually, the giants of the Carboniferous disappeared, giving way to new rulers, reptiles, which would later pave the way for the rise of the dinosaurs. Yet even today, we can still find their descendants among the ordinary insects that fly through our gardens and forests. They are no longer as massive as Meganeura or as terrifying as Pulmonoscorpius. But their history stretches back hundreds of millions of years to a time when the world belonged to the giants of the Carboniferous forests. So now the question is yours. Why did insects grow to such sizes? How did they hunt? What terrible predators ruled the prehistoric forests? What if you were in this prehistoric world? Would you be able to survive among megapredators? Which prehistoric creature would you least want to meet face to face? Write your answer in the comments. And don't forget to like the video and subscribe to the channel to explore more incredible worlds of the ancient past. Support our project. If you like what we create and want to help us work on new releases, join us. Subscribing and liking is an easy way to say thank you and inspire us with new ideas. This is a step towards new stories and releases. Thank you for your support.